Problem 7, we have line segment EH is divided by F and G in the ratio of 5 to 3 to 2 from left to right. If EH is 30, find FG and name the midpoint of line segment EH. Well, if EH is split up into the ratio of 5 to 3 to 2, I can say that EF would be 5x, FG would be 3x, and GH is 2x. Because if there's 10 total segments, and one segment is x, then I'd have 5x, 3x, and 2x. Combining like terms, I'd have 10x. The whole segment is equal to 30. I divide by 10, so x is 3. Plugging that back in to find the lengths of my segments, I'd have EF be 15 units long, FG is 9 units long, and GH is 6 units long. So line segment FG is 9 units long, and my midpoint of EH is point F. Because EF is 15 units long, and FH is 9 units long and 6 units long, which is a total of 15 units long. So they're both 15 units long, making F the midpoint of line segment EH. Looking at this sample problem, we have points R and E trisect line segment PO. So that would mean line segment PR is congruent to line segment RE, which is congruent to line segment EO. We have point E bisects line segment PV, so therefore line segment PE would be congruent to line segment EV. I have PR is x plus 4. I have RE is y plus 6. I have EV is 2x plus y plus 6. And I want to find OV. Now there's a few things that I can start with. I'm given line segment EV is congruent to line segment PE. I know line segment EV is 2x plus y plus 6. Line segment PE would be line segment PR plus line segment RE, so that's x plus y plus 10. Solving this now, if I subtract x and subtract y, that would give me x plus 6 is equal to 10. Now subtracting 6, I would have x is equal to 4. Now I also know that line segment PR is congruent to line segment RE, so x plus 4 would equal y plus 6. Well, if x is 4, that means 8 is equal to y plus 6, so y is 2. So now I have x and y solved for. Let's solve for my segments. So if x is 4, line segment PR would be 8. If line segment PR is 8, that means line segment RE is 8, and line segment EO is 8 because they're all congruent. Now I can solve for line segment EV, so 2x plus y plus 6. If I plug in 4 and 2, I'd have 2 times 4 plus 2 plus 6, which would give me a total line segment EV of 16. Now if I look at my diagram at line segment EV, notice OV I could find by subtracting EO from the whole line segment EV. That would mean line segment OV would be 16 minus 8, which is a total of 8. So line segment OV is 8 units long. Looking at this sample problem, we have angle BAC is 3x plus 15. Angle BCA is 5y plus 6x. Angle DAC is 7y plus 1. And angle DCA is 9x plus 4. I have ray AC bisects angle BAD, making these two angles congruent. I have ray CA bisects angle BCD, making these two angles congruent. I want to find angle BCD. So, using my two angles that are congruent, I can create a system. So if 3x plus 15 is equal to 7y plus 1, and then 5y plus 6x will be equal to 9x plus 4. Rearranging some variables, I'd have 3x minus 7y is equal to negative 14. and negative 3x plus 5y is equal to 4. Now if I have negative 3x plus 5y is equal to 4, using addition, I'd have negative 2y is equal to negative 10, so y is equal to 5. Taking this, solving for x in one of my equations, I could have negative 3x plus 25 is equal to 4. So negative 3x equals negative 21. So x is equal to 7. Now that I have x and y, I can plug it back into one of my equations to solve for the angles. Now, since the angle is bisected, I can find one portion of the angle and then just double it. So if I plug it into 5y plus 6x, I'd have 5 times 5 plus 6 times 7. But I'd need two of these because there's two of the angles. So 5 times 5 is 25, 6 times 7 is 42, 25 and 42 make 67, 67 times 2 is 134. So angle BCD is equal to 134 degrees. In this lesson, we learned how to solve problems that deal with division of segments and angles. That's a wrap on this video. We'll see you in the next one.